All right. So let's get rid of that. So this is going to be section R4. And here's the title to it. Okay, we've started now. Kyle? Oh, I'm sorry. I was looking at my side of my... It's Ray. Ray, look up here. Sorry about that. I wasn't looking directly. I was looking... Well, I knew you sat there. Because I couldn't see you. I just knew that you sat there and I could hear it coming from you because I was looking at the screen. So, polynomials. What in the world are we talking about polynomials? Well, it's not really shapes. No, it's the nomial. I don't really know where that really comes from, but it's terms, okay? So we'll think of it as terms as far as algebra is concerned, okay? The word poly, we should know what that prefix means. What does that mean? It means many, okay? All right, so it basically means many terms. Well, let's do one that's not actually many, but it's actually just one, okay? So that's even considered a polynomial. So if I have one term in algebra, and we'll talk about what a term is here in a second. If I have one term, we have a name for that. It's not just a nomial. It's a good guess, though. There's a prefix before the word nomial, and it's one. Bi would be two. Okay, it's monomial. Okay, and so mono, right? Mono means one, so it's one term. What does that mean to be a term? Well, if I had, let's see, sometimes they get really picky about this, but let's say I had x to the fourth. This would be one algebraic term, okay? There's just one thing. Now, if we're going to have more than one, it's always separated by addition or subtraction, okay? Is anything being added or subtracted to this? No, it's just one thing sitting there by itself. I could have made this like 3x to the fourth. Still, is there anything being added or subtracted to this? No. So this is still considered a monomial, all right? Even just a number sitting there by itself would be considered a monomial because, and you say, well, that's not algebra. It doesn't have any variables with it. Well, it kind of does, though, because I could write this like that, all right? So these terms have variables in them, all right? That's one of the things. They have variables. They have exponents. So this would be an exponent. This would be a variable. This right here would be a coefficient. Have we used that word in here this year? I think we have. Can't remember. But the number out in front of the variable is called a coefficient. So even just the number 3 would still be considered a term because it has a variable being multiplied by it. Because what's x to the 0? What's anything to the 0? It's not 0. 1. It's 1. Okay, so what's 3 times 1? It's just 3. So this would also be considered a term. There's just one term, so we consider that a monomial. All right, you with me? Even if you had negatives, even if you had like a negative, that is still considered a monomial because you're really not subtracting it from anything else. Well, technically, I guess you could say you're subtracting it from 0, but we're not going to count that, all right? So that's a monomial. And then we're just going to do 3 of them. So what if you had 2 terms? What's the name for 2 terms? It's a binomial, okay? All right, so we all know this, and for the wrong reasons, we probably know what the prefix bi means, if you know what I mean. But we do. Bicycle. I'm actually in the market to buy a bicycle. So a bicycle has 2 wheels. So we call that a bicycle because of the prefix bi. But right here, this means we have, come on now, come on, grow up. I mean, we said something mildly funny or mildly, I don't know, offensive maybe to somebody. Just watch, okay? It's not that big of a deal. I don't have to lose the whole class because of one little silly statement. So let's pay attention. You could giggle once, right? If you giggle, I don't know. You could laugh once, and then you focus again. All right? You guys go off until the teacher stops you. I don't understand that. Just like, oh, that was funny. And then, boom, it's done, right? Then you move on. That's how it should work. So let's take a look. So binomial means 2 terms. So here's an example of a, I should have done something else. But that's all right. What if you had this? What if you had like 2x plus 3x squared? Is this a monomial? No, because what did we say about if you had more than one? They have to be added or subtracted to something else. So this is a monomial. That's a monomial. They're being added together. That means there's two terms, right? There's two terms. We call that a binomial. The reason we're going to do that is because in this lesson, maybe not today, but maybe in a day or two, we're going to do a lesson with binomials, and we're going to talk about binomials, and they're really, really important. So you need to know what I'm saying when I say the word binomial. Now, obviously, if you had three terms, I don't know, maybe it's not obvious, but if you have three terms, I think it's obvious. What is it? Trinomial. Very good. Okay, so that would be a trinomial. So for instance, a trinomial would be, I'm just making this up off the top of my head. What if you had like 5x squared plus 3xy to the fourth minus 7 a, b, c. Okay, they don't even have to be all the same letters. Okay, if you have something like that, that's three terms. Okay, that would be considered a trinomial. Again, we're going to do something mathematically. We're going to learn a lot about things that are called trinomials. We'll do a thing called factoring. You remember factoring from Algebra 2? Yeah, you might have done a little bit of that in Algebra 1, but you really went deep into it in Algebra 2, didn't you? With factoring. So we're going to factor binomials. We're going to factor trinomials. We'll talk about what that means in a little bit. All right. Here's an example of things that would not be considered a nomial, okay, or a monomial or binomial or something like that. So what if you had this? And I didn't really explain this before, but when you have an exponent that's not greater than 0 or 0 or less, okay, I'm sorry. Yeah, it could be that. Let's use this word. This, in order for it to be a polynomial, that would have to be an integer. Do you know what integers are? You probably learned that in Algebra 1, didn't you? An integer starts at 0 and then it goes what? 1, 2, 3, and then what? Dot, dot, dot. Remember that in Algebra 1? Pre-algebra? That's an integer. So this has to be an integer. Right now, is that an integer? No, it's not, because it's not 0 or 1. It's in between. The in-between stuff are not integers. So in order to be a polynomial, this thing right here has to be an integer. And another thing would be right here. Is that an integer? Because what's the smallest integer? 0. So anything less than 0, I'm sorry. I should say this, I'm sorry. It's got to be a positive integer. Sorry about that. I didn't write that down. I should have written that down. Okay, yeah, it's got to be a positive. Oh, actually, I do have it written down, and I didn't even see it. It has to be a positive integer. Okay, so this exponent has to be a positive integer. To tell you the truth, watch this. These are also integers. Oops. Okay, dot, dot, dot. They're also integers, but they're not what? Positive integers, okay? So in order for your exponent to have a polynomial, your exponent cannot be negative integers, and they can't be fractions or anything like that. Everybody with me on that? It's really not that big of a deal for what we're going to do a little bit later on, but just know what a binomial is, know what a trinomial is, and you'll be good to go. So now we're ready, probably on Thursday, to get into actually doing some real math with this stuff. Do you remember FOIL method from Algebra 2? We're going to be doing some of that. Distributive property, we're going to be doing some of that, okay? We're going to add like terms. Remember doing that? That's all got to do with polynomials. So that's what's coming up next. Okay, maybe some of you guys are excited about that because, yeah, I knew that stuff. I was good at that stuff. That's what's coming up next.